I did not bring my headset. I'm hoping you can hear me okay. And I'm out of time to try to use my Bluetooth headset, so we're just going to go with this. So, why is this not full screening? Full screen, please. There we go. All right, so, hi guys, hello and welcome. And for the stream, hello, welcome to Code Soul. Today we will build a data pipeline with Prefect. It's not going to be super fancy, but it will be quite complete. And it should be something that you could use as a base to start building something more productionalized. In terms of what is and is not suitable for production, I will cover that stuff as well. Of course, as usual, this will not be perfect. I am not an expert. I have not written a book on this stuff. I'm just sharing the knowledge that I have with you. Also, I am not the data pipeline guy in my company. Someone else set that up. This is stuff that I have learned independently. So we'll see how it goes. So we're going to start, adding introductions of the speaker because we hope to have more guest speakers. So I'm Beege. I've done a whole bunch of different stuff like data engineering before it was called data engineering, and before we had fancy tools like Prefect. I've worked at these places. That's totally a doctored photo of me. It's a good time, but that's less important. Right now I work as a product manager. I do work with data engineers every day, and there's a lot of work to be done. So we're going to cover a little bit of the stuff today. So, today, we are going to cover just a few things. What is data engineering? Okay, what is the discipline? What kind of work do data engineers do? What are data pipelines? Basically, when we want to move data from A to B, how do you do that? Then more specifically, we'll talk about Prefect, which is the tool we'll be going over today. We'll go over how Prefect works, its different components, and then we will spend the rest of the time actually writing some code. Now, quick aside, there is, I do recommend going to our GitHub while I'm talking, okay? And if you go to repositories down here and intro to Prefect, I do recommend cloning this down. Don't look at the complete branch, that's the end version of it, okay? But go ahead and clone down this project because I don't want to have to go through all the boilerplate with you again. I will review the boilerplate briefly, but I don't want to sit here and make sure everyone types things properly and handle all the typo errors and all these kinds of things. So do please, are you here for the beginner event or the data engineering?
Yeah, the beginner one.
Out there with those guys. Cool. Right, please clone this down. We will use it. So let me just pull this off to the other screen. And what do I do with it? I'll just do that for now. And let's get back into the presentation. Okay. So, that said, let's continue. All right, so what is data engineering? It is, managing data. Now, a lot of people get confused. They think that data scientists and data engineers are the same thing, or they think data engineering is something that data scientists do. Data scientists often do data engineering in smaller companies where they just don't have enough people to split both jobs, or where they don't realize how important data engineering is, or when their data volume is not big enough for it to really be a problem. In terms of the kind of work that data engineers do, they build databases, they build a lot of data pipelines, and they also manage infrastructure. And whenever you're writing code and managing infrastructure, you also have to account for cost. You have to worry about things like security. And often, data engineers kind of rescue the data scientists. Data scientists are like, oh no, I need this data to be able to analyze things, or I need this data to, or not only data scientists, also machine learning engineers. I need this data to add as a feature to my model, otherwise the whole thing won't work. And data engineers like, I'll get your data, just give me 3 days or something, or whatever a reasonable timeline is, depending on the complexity of the data and all that kind of stuff. So at a high level, does that make sense for the kind of work that a data engineer covers? I see hesitation. Sure? If questions come up at any point, please interrupt me. Correct.
So it has no relation to the two.
So just for the benefit of the stream, Martin was talking about CI/CD pipelines and curious if there was any kind of relation to data pipelines. So in like pure raw theory, they're actually quite similar. They're both just task runners. It's just they are suited to different tasks. In practice, they are very different. So CI/CD is usually triggered by a Git action or by a human action, preferably Git. Data pipelines either run in response to the state of change in data or no. Either an event, which could be a state and change of data, or on a schedule or on demand. But in essence, they both just run some code and then, track it, log it, all that kind of stuff. Does that make sense?
That's cool. I thought my question was stupid, and it's less stupid than I thought.
That's good. That's why we should always ask questions even if we think they're stupid, because sometimes they're less stupid than they seem. Now when it comes to, going into a little more detail here, when we talk about databases, we're not just like, oh, you stand up MySQL and you're good, right? No. There's much more to it than that. You have both relational databases and non-relational databases. Maybe the application whose data you need to pull from is in MongoDB or DynamoDB or Cassandra or one of these other non-traditional relational database management systems. Or what's more likely is people don't want you touching their database and they want you pulling from APIs instead, right? Or maybe you've decided, hey, for purposes of analysis, maybe I need to use MongoDB or whatever. And in terms of data pipelines, there's a whole bunch of different technologies you could use. You could use Prefect, like we're talking about today. You could use Airflow, which is more popular. You could use Luigi or a number of other different data pipelining engines. And in terms of infrastructure, it's not only servers. You also have to manage your storage infrastructure. So a lot of companies use object storage, and they use it as a data lake. Not going to cover data lakes today. Or if you have kind of event streaming pipelines, you want to use message queues, right? Or you need to manage the database servers themselves, right? So there's actually a lot more work than just these brief bullet points, right? This is a very high-level summary. So any questions about that? Cool. So what exactly are data pipelines? Well, in their earliest form, they were just a bunch of scripts probably run by cron. Like, that's actually what I did. When I said I was a proto-data engineer, that is exactly what I did. We had a bunch of cron jobs running Bash and Python scripts because we had no idea what we were doing. And it was, difficult to log, difficult to troubleshoot. But we were kind of building our own framework around things. But now there are frameworks that already exist. They're way better than the stuff we were building. And now there's a whole bunch more theory around different types of data pipelines and different practices around them. So there's two main categories of pipelines. There's plenty of other smaller categories as well, but most of the time they're grouped into these two groups called ETL or ELT, depending, which are generally batch pipelines. Basically, at some interval, you take a bunch of data, you move it from A to B. And then streaming data, where as data is coming in, you consume that data and you send it wherever it needs to go. Now, streaming data can be very high rate or it can be very low rate. It depends on the application, it depends on your company's needs, all this kind of stuff. Or you could have a combination of the two. Maybe you have a streaming pipeline that sends to some kind of staging area, and then you have a batch system that pulls from that staging area and sends to your data warehouse or something. Anything and everything works. So in terms of your batch data pipelines, where you're just taking large amounts of data on some interval or on some trigger, you'll often pull from databases directly. More likely, you will pull from APIs, right? You see this very often of pet and toy projects where they pull from the Twitter API, something like that. Or sometimes it'll be straight files. And that's especially true of when you have communications between companies. Sometimes they'll just SFTP a file to you, and then you do stuff with that file. On the streaming side, it's mostly message queues are kind of the big thing, especially the publisher-subscriber model, if you're familiar with that, or kind of polling data on a regular interval, usually kind of tight intervals. So that usually ends up being API calls, and that's when the definition between batch and streaming gets a little bit fuzzy, but you get the idea. Questions about this? No? You good? All right. So the presentation is going to be really short if you haven't figured that out yet. So going on to more specifics, what is Prefect? So Prefect, I actually forgot to say here, it is open source, but there is a company that backs it. They have Prefect kind of as a service. Well, kind of as a service. They have the management of Prefect as a service, but you write the pipelines yourselves. But you can run it on-premise locally, or on your own cloud. That's actually what my company, the company I work at, does. It is an orchestrator, right? So it organizes and triggers tasks, manages which tasks are run by which workers, these kinds of things. It is a pipeline framework, so it has a whole bunch of libraries to help you write pipelines in a sane and easy manner. It provides logging and visibility for your pipelines, so you can see when errors happen, you can see progress if you wrote such logs, and then you can see visibility as to what tasks are running now, how many instances of the task are running, how long did they take, these kinds of things. It's also a web application, because to show you all that logging and visibility, you need some kind of interface to see that, so it acts as a web server to do that. If you have heard of Airflow, it is an alternative to Airflow. Airflow is far more popular, but I'm not showing you guys Airflow because I don't know Airflow yet, because I haven't needed to. We ended up choosing Prefect because in the past we had one team that tried Airflow and they hated it, and when I asked them why, and I went to search for information around how to solve those problems, Prefect solved all those problems. So I was like, well then let's just use Prefect. But Prefect is not very popular, and I don't know Airflow well enough to say one is better than the other. That was just the experience I went through. There are far more engineers who use Airflow. So if you're like, which one should I use? Determine if you want to do something that might be a better developer experience or that has more engineers that you could easily hire. But also, again, our experience with the developer experience of it may not necessarily be better. That's just what we went with based on discussions. I don't mean to generate any competition between the two. Airflow is more popular, but we're doing Prefect. It is cloud compatible. And what I mean by that is you can deploy it on Kubernetes. It works easily. It works smooth. Well, yeah, mostly easy. It works smoothly. Prefect version 2 did release, I believe it was this year. And there's still a couple of things they're working out, but generally it works quite good. And at least anytime we encounter an issue, we submit a pull request to fix it, so it should be getting better. And it is on-premise capable if you want to run it in your data center or whatever. So questions about Prefect at a high level?
Uh,
I see the gears turning.
So when you use the web application, what actions can you do?
So the question was, when you use the web application, what actions can you do? You can observe flows, so you can see what tasks, you can see what pipelines are running in a given moment. You can trigger pipelines, you can set schedules for pipelines, basically a lot of the configuration, and then like triggering things and observing things. Does that make sense? And when we do our demo today, we'll actually, or not demo, when we do our workshop, because we will build things together, we'll actually show the UI and we'll work in it to do stuff. Now, that said, everything that you can do in the UI, you can also do via their API. So if you want to automate things, that's cool too.
Do you prefer to work in the console or in web app?
So the question was, do you prefer to work in the console or the web application? When it comes to doing manual work, when it comes to doing manual work, usually I prefer the console. But with Prefect, I prefer the web UI. Just because they did a really good job with it. It's really pretty. And it's quite easy to navigate and use. There is a little bit of a learning curve. There's a couple of design choices that I don't necessarily agree with, but once you're like, oh, the button's over there, okay, then it's easy. And the operations are pretty well suited to UI stuff. Like if you want to view like how tasks have run over time, it's much easier to see that graphically than on the console. So yeah, it's more stuff like that. It's more the visual feedback than so much like the triggering commands and stuff that I prefer the UI. Does that make sense? Cool. Other questions? All right, let's go on ahead, and if you have more questions, you can let me know. All right, so how does Prefect work? So I'm just briefly going to go over what are the different components within Prefect, the interactive components within Prefect, the parts you would work with, and how you use them. So first off, are you guys familiar with a DAG? D-A-G. One yes, one no. Okay, so DAG is a directed acyclic graph. Acyclic? I don't know. My English is terrible. But it's basically a pipeline. You have some input, a bunch of steps happen, and you have some output. Done. Directed being this way, graph being nodes and edges, all that sort of good stuff. Acyclic being it's not in a circle. So really, a flow is a series of tasks that run together as a single unit. So if you want to trigger a pipeline, you trigger a flow. Okay. Tasks are steps. Excuse me. Tasks are steps within a flow. So when you cannot trigger a task individually, you have to trigger things at the flow level, and then each task is kind of like an atomic action within the flow. Basically, it's a function. A task is literally a function in the code. Now, the nice part is each task does have its own logging and like time checking and all this kind of stuff, so it's worth it to break your flow down into tasks, especially because there's retry logic and stuff like this. There's also deployments. Deployments are kind of the metadata of how to run a flow. So basically, it's just the information on how to run a flow. Okay, so it's deployed on this kind of agent, and this is how you can run and trigger it. There are work pools and workers. So the Prefect server is just the orchestrator. It doesn't actually run the pipelines. You create Prefect agents, which is just, kind of daemon software. You can run it in Kubernetes. You can run it in your data center. You can run it wherever. It's just software, right? And these worker agents connect to the Prefect server and say, "Hey, I'm ready to do work. These are the flows I can run. Just let me know when I should do stuff." Okay, so those are workers, and then you group them into worker pools. So, for example, let's say you have a Kubernetes cluster, and you're like, "Hey, I want to do a whole bunch of work." You can say to the workers, "Hey, scale out, do this work." Or you can say to the work pool, "Scale out." It'll create a whole bunch of workers, do this work, all that sort of good stuff. Now, that said, Prefect does not do the scaling on its own, and it does not do the dynamic worker distribution on its own. It uses other libraries, notably Dask and Ray, to do that for you, but we're not going to cover that today. That's more advanced. But it is possible. We do it every day. We have jobs that spin up 100 servers, get the job done in like 30 minutes, and then tear down those 100 servers. Each running like 2 GPUs and all the crazy stuff, because we do a lot of machine learning stuff using Prefect. So it works well. There are also schedules, which are exactly what you think they are. You can schedule flows to run at certain intervals, so you can make them run hourly, daily, whatever. You can actually store results in Prefect, but we don't really use that. We want the results in like our own databases that we can do other stuff with. And then there are blocks, which are basically configurations for a flow, and you can manage them from the UI. Honestly, blocks are something new to Prefect 2. I knew more about Prefect 1. I'm not 100% sure on blocks, and we're not going to touch on them today, but they are important. If you do want to run Prefect in production, you should learn how blocks work, because you will need to do those kinds of configurations. Okay. So any questions about this stuff? Cool. All right, so let's get coding. Let me pull up the correct window here. So I'm going to assume that you have, oh God, where are all of my tabs? Okay, give me a moment here, I'm sorry. Looking for, that's the one. I assume that you have cloned down this repository, because that's what we're going to run with. Again, the complete branch has the complete working version of the code. Please don't look at that for now. You will learn better if you work on it with us together. But let's get back to the code. But I will totally have the complete version up so I can use it as a reference. On that note, where... Oh, wrong branch. Wait. Huh. Weird. Oh, no. I'm sorry, guys. Give me a second. I might have messed up the repository. Is that committed? That is not committed. Did I just lose all of that? Well, we're going to find out. Let me check something here. Yep. That's gone. Okay. Some of the code we're just going to have to figure out on the fly. It'll be great. I assume you're using Visual Studio Code or something like it. Heads up that I did install one of those AI code assistants, and it's a little bit, actually, you know what, let me just disable it. Give me a second here, because I don't want to, I do not want to talk poorly about something. Yeah, let's just disable it for now. Okay, that should be fine. All right, great. So yeah, you should have this repository, and I'll just go over the repository contents for now, just as a review of how I set up projects. Definitely going to have plenty of time. So, as usual, pyproject.toml. We will need these dependencies. We're going to install Prefect itself. We're going to use HTTPX as our HTTP request library. Crap, I'm sorry guys, I forgot to turn on the lights out there and it's starting to get dark. Give me like 30 seconds. Okay, sorry about that. That door closed from the wind. All right then. Right, so HTTPX is going to be our HTTP request library, and then we're using PsychoPG2 as our Postgres client, the binary one, because I don't feel like building Postgres client from source. Additionally, I always use pre-commit to format my stuff to do linting. Those of you who have been here before are familiar with that. And then we use this pipeline script so that instead of having to write out the whole Python command, we just say pipeline and it runs. So if we do a test here, just to make sure everything's cool, if I go into source, pipeline, main, and I say print, hello world, save, I type in pipeline, hit enter, we get hello world. Oh, I don't have so the configuration expects that there's a main function. We have not written that main function, so it's complaining. But it's fine. It's configured correctly. So that's it for that configuration. For the README, go ahead and just copy and paste this block and run it. Okay? Some stuff is going to run in the background. That's cool. You probably want to run... Actually, yeah, you can just run the whole thing. It's fine. I'm sorry? No. Sorry, that's just to get it to render properly. Where's my render? What? No. I want my markdown render. Yeah. That's just to get it to look like this. That's it. So we could just hit enter, do all the things. So the first one here creates our virtual environment. The second one activates our virtual environment. Third one installs all of our dependencies. Fourth one sets up pre-commit. Next, we do Docker Compose, and I'll go over in a minute what exactly we do with Docker Compose. Then we configure Prefect to use a local Prefect server instead of Prefect Cloud. And then we go ahead and run our Prefect server, except I already have it running, so I encountered an error. If I just kill this shell and go over here, you see I have it running in that other shell, so that's why it failed. So it's going to take a couple minutes for you guys because you're going to have to pull down a whole bunch of Docker images, and that's okay. We're going to talk about stuff while you're waiting for those pulls to finish. Is that okay? Are you guys good to continue? Do you need help? Oh, okay then. Yep, that would be a problem. Okay.
But my Docker's okay.
All right. All right, we'll just continue then. Do you have ASDF installed? The command line utility. Because usually I recommend people use ASDF. It's a nice little software version management utility. If you just hit, if in terminal you just hit ASDF and enter, it'll complain to you if it doesn't exist. Otherwise, it'll give you help. All right. Should I continue, or do you want a couple minutes to get that sorted out? Okay. So then let's go ahead and continue. So in terms of the Docker stuff, we have a Docker database container or Docker service called database. It's going to run the Postgres image. We set up, username, password as just root, and we're naming the database pet store because we're going to pull from the Swagger Open API pet store example API. And we just make the ports accessible on our host machine, and then in case we need to do any troubleshooting, again, this is not something you would do in production, this is just for local development. And then we set up a volume so that the database's data can be persisted beyond the lifetime of the container. And then we set up a initialization directory where the Postgres image will read any SQL files and execute them when it first starts if data does not exist. Key part being if data does not exist. If you set up this container before, then the database will already be initialized and it won't trigger your initialization scripts. So if you've already run the container and you want to add initialization scripts, you should delete the container and delete the volume. And then when you bring the container back up, it'll trigger the initialization scripts and all that good stuff. So that's just a mild pain that you should be aware of when doing that. Does that make sense? Cool. Then you guys probably know by now, I like to use adminer to inspect the database contents because I don't want to have to do all the client configuration stuff. I just want to look around and click because I'm getting lazy and I'm not technically an engineer anymore. So command line is anyway, I'm joking, of course. And then we define our volume to be used as the data volume for the database. So does this all make sense? Do you guys have questions about this one? Cool. Now you might be wondering, why don't we run the Prefect server in Docker Compose? Well, because I couldn't get it to work. The Prefect server actually tries to run Docker Compose internally, and I just did not want to deal with that, so we're just running it directly. There is a way to run Prefect server in a Docker container without Compose and all that kind of stuff. We have done it at my company, but I don't know how we set it up, and I did not have enough time to prepare. I prepared this whole thing in 2 hours. So yeah. But it is possible, I just did not do it today. Moving forward. And then pre-commit config is just a whole bunch of linting stuff. Who cares? And git ignore, you know that. License, all good. So any questions about the basic project setup stuff? You're probably familiar with it by now. All good? Cool. What's up? Oh, okay. So let's get into it. So first off, I probably should have set this boilerplate up already, but I just forgot. So let's define a main function because that's what our PyProject.toml expects. And then let's set up an entry point, a standard entry point like this. This is sit and watch Beege type time, right? I promise it's not going to be this the whole time. So, this is just to make sure that if we do, in our main, if we do print hello world. I thought I turned the damn thing off. I hate this thing. And then we go to another thing, and if we just type pipeline, it'll run this. I thought I turned off this damn thing. Okay, anyway, I'm just going to commit this because this is what should be. Cool. Push to main. What could possibly go wrong? All right, so that's our boilerplate. Now, time for actual prefect stuff, right? So ideally, if you ran your pip install, you should have all the dependencies already. So we're not going to go back and forth as to setting up all the dependencies. You can look in the PyProject.toml for those. So let's dive into it. So let me also pull up my reference just to be sure, just to make sure I don't spend a bunch of time messing around with nonsense. Yeah, okay. So earlier we talked about flows and tasks, right? So a pipeline is a flow. So we're going to start with a flow. So first we're going to, from prefect, import flow, and I really apologize for all of the red. Please ignore it. You know what, let me try one more time to turn it off. This is driving me nuts. What is this goddamn nonsense? Reload required. That's why I didn't reload. Okay, there we go. Sorry, guys. Okay, there we go. Much better. Now we can read. So we're going to import our flow. Now, in prefect, this flow is actually a decorator. So we can define a flow, and we're going to call it, I just want to be consistent here. Make sure I named it the right thing. What did I name it? All right, we're going to call it, why did I call it that? That's wrong. Okay, I'll fix that later. We're going to call it, we're going to make a new function called collect pet store inventory. Inventory Beege, there we go. Because that is the pipeline we're going to write today. Okay, we're going to, right, sorry, before we dive into it, let's actually understand what the problem is that we're solving. I also forgot to show you the database stuff. You can tell I had totally had plenty of time to prepare this. So the Swagger Pet Store. So what we're going to do is, there's this Swagger Pet Store. Swagger is, the documentation tool. And, they have an API. Specifically, they have this inventory endpoint. It returns pet inventories by status. So if we try this out, we get some data. Now, you'll notice it's a little dirty, right? What the hell is this? Why is string a type of inventory? String is not a status code, right? So this is perfect, though, because we should, as a data engineer, you will have dirty data. You will have to clean up that data. So we'll go over that a little bit. So this is the endpoint that we're going to collect data from. Okay? And in terms of what we want to do with that data, we're just going to store it in our Postgres database. I mentioned earlier the init scripts. I've defined this table. Let me make this a little bit bigger for folks. Okay, that's more than a little, but we'll run with it. I defined this table, inventory history. It uses a timestamp as a primary key, which is not the best way of doing things, but again, this is just a toy example. Although depending on a bunch of stuff, it could be the best way to do it. It just depends. Postgres actually has a time series storage engine, I believe, if I recall correctly. It is not the default storage engine. It is not what we have configured, but we're just going to run with it. And we want to track the sold, pending, available, and unavailable pets over time. Okay? So timestamp and then counts of each of those. That's what we're tracking. Nothing super fancy, nothing too complicated. We mean the purpose of this is not to focus on interesting problem solving, but to focus on demonstrating technology. So we're keeping the problem simple. Questions about the problem we're going to solve? So it's get data from API, clean data, dump data to database. GG easy. Okay? So let's get back to it. So we're defining our flow's name is going to be collect pet store inventory, right? We want to decorate this with the flow decorator. Now, technically, you can do all of your logic in a flow, but we're not going to do that. We are going to, or no, we will not do that for the final version, but we will do that for the beginning. So what we will do here is let's go ahead and where's my thing? No, where'd it go? There it is. We're just going to grab this URL here. Okay. And yeah, that's what I want. Okay. And, we're going to just, this is not going to be perfect. Just roll with it for now, right? This is not how you should input URLs, but one step at a time. We'll make it better in a minute. And then we're going to get the response using the HTTPX library, which we will have to import. Okay. So if you're using Visual Studio Code, you can just highlight or put your cursor over this, Control dot, and say add import. It'll do it for you. And then we want to do, we should check the response status. So, raise for status, basically if it fails for whatever reason. And then we want to collect the inventory stats. So let's store the inventory stats in a variable called inventory stats. And we'll retrieve them as the JSON body response. And then let's go ahead and just print the inventory stats for now. Okay? So I'll give you guys a minute to type all that.
My drive was full because the Docker was not.
Oh, jeez. Do you need help cleaning up your stuff?
No. I cleaned it up. Now I'm installing the 24 gigabyte file.
Wait, what? 24 gigabyte file? What?
24 megabytes.
Oh, 24 megabytes is much more reasonable.
Megabyte. That's how well I prepared.
Oh man, okay. Yeah, Docker prune is your friend.
Yeah, I need to take some time.
Yeah. Yeah, make sure that whenever you finish doing stuff with Docker Compose, you do Docker Compose down, so it removes all of those containers. And then you can do Docker prune safely and easily, and it'll clean up all the unused junk. All right, so you guys are good on this? All right. All right. So now you should have the Prefect server already running. If you ran this command right here, we've configured our local Prefect environment to point to that server. So given all of that, let's go ahead and, oh no, okay. Let's go ahead and run our pipeline command, because that's what we aliased everything as. Wait. I am so sorry. We forgot something really important. We defined our flow. We haven't actually run it. Now, with Prefect, the way it works is you have the Prefect server as your orchestrator, and then you have the agents who actually do the work, right? So something needs to act as the agent. So what we do is we take our flow, right? And we say serve, there we go, as pet store collector, I guess. I don't know. Or pet store collection deployment, let's say. And with this deployment, I cannot type. So as the docs states, this creates a deployment for the flow. and then whatever this running code will act as an agent to run that flow when the server requests it. Okay? So now, we defined our flow here. In our main function, we serve the flow as an agent dedicated to running just this flow. You can configure agents to run whatever flows, but we're not covering that today. We're keeping it simple. So now if we just do pipeline, you'll see that this running Python interpreter is bound to this collect pet store inventory flow. It has connected to our Prefect server, and it is waiting for the server to say, hey, please run the flow now. Okay? So now we can just grab this URI, and nope, that's not what I wanted. I wanted to do this. Or I can just control click, and I'll do this one. And then we can go to our browser, we can paste this, and this will take us straight to, oh, I didn't show you guys the server yet. Hello. Cool. All right, let's do it differently. I don't know why that's not working. That's quite odd. Let's just go to localhost :4200. Ignore all those failed jobs. That's just wait, where's my successful job? Oh, anyway. This is what the Prefect server looks like. So as we discussed, there's flows, deployments, work pools, blocks, all these kinds of things. Ooh, variables. I didn't get to look at that yet. I'll have to look at that later. Is this? Oh, baby. Okay, I will check that out later. Oh, actually, the other guys on my team have already figured it out. Anyway, the dashboard shows you flows that have run. It shows you how many flows have run and their status. It also shows you individual tasks. And it also shows you basically work pools, which again are just Prefect agents that are capable of running flows, like we explained earlier. So what we want to do now is we can check that, hey, here's our collect pet store inventory flow. You can ignore these. These were from my preparation earlier. So we have this collect pet store inventory, and we have our deployment, pet store collection deployment, basically the code that's running right now. Basically, this guy right here, okay? So what we can do is we can go ahead and say run. We can just do a quick run. And then it automatically creates a name for us. We can hit view run. And there we go, it ran. Now, you're like, Beege, what is this? Right? So we just printed to the screen, right? Prefect has its own logger, okay? But we did not use that. We just printed to the screen. But we can still verify that what we ran worked. If we go back to our agent, you can see here, these are the inventory stats that we printed. Okay? Make sense? Cool. But maybe we want this to actually be part of the logs. So, Prefect has this built-in function called get run logger. And we can import that. And then we can, in our flow, we can create a new logger object and say, hey, here's my get run, I want to get a run logger. And I'm going to store it in logger. And then let's just store this logger.info, just like any other normal Python logger. Well, Python doesn't have interfaces, but if it did, it would be like implementing the Python logging interface. So yeah, now we changed our flow, right? So we should kill our deployment, run it again, okay? And now because the deployment has the same name, the Prefect server won't really care that we ran a separate instance. So what we can do is we can just go back to the deployment and we can say run. And we'll just do a quick run again. So let's view that run. You see it shows up here. Let's give it just a moment. There we go. And now you see our results got printed here, okay? So if you do want to, if you're debugging your flow or whatever, making sure you get the Prefect logger, the get run logger, is quite important. Do not forget to do that, otherwise debugging this will be a giant pain. Cool? Or maybe not a giant pain, but then you have to keep bouncing back and forth, and not fun. Okay? So questions about what we have so far? So the way that this worked is, this is the Prefect server. When we ran this pipeline deployment, this started a Prefect agent. That Prefect agent registered with the Prefect server. From the Prefect server, we said, hey, this deployment, which is that agent, we want to run this flow. And then the server told the agent, hey, run the flow. The agent ran the flow, and it reported the logs back to the server where we could view them. Okay? Does that make sense? Standard kind of like orchestration architecture. I see some gears turning.
It's just new.
Yeah. All right, cool. So that's all great, but this has not solved the problem yet. Like, yeah, we got the stats from the inventory, but A, this data is junk, and B, this is not inserting to a database. Okay? But we don't want to do all three of those things as a single step, right? We probably want to, retrieve the data as one step, clean the data as another step, and then insert it as the final step. That sounds reasonable, right? So let's go ahead and do it that way. So from here, let's also import task. Task is another task. I sound Korean when I say that. So tasks, again, are meant to be kind of atomic functions that you tie together into a flow. Splitting your flow up into tasks makes things like retries easier and allows you to do all sorts of like scaling out and branching logic and all this cool stuff. So, all that said, let's go ahead and take all of this logic and let's make a new method that's going to be a task. And let's say def retrieve from API. Let's just call it that for now. And then let's paste our logic here. Now, and then in our flow, we want to retrieve from API, and we want to store inventory stats. Okay? Does that make sense? This is pretty reasonable to folks? Cool. So, now we can get fancy here. These can accept inputs, right? So we can say, hey, maybe I want to split up this URL. Maybe I want to have like a base URL, right? And maybe that defaults to here, right? And then maybe I want, the path, which is also a string, right? You can do something like this. And then maybe I want, a secure flag, right? Boolean default to true. And then we can do something like, if secure, else. There's a reason I'm doing this, I promise. And then we can do something like this. I cannot type. Now this is a bit of a contrived example, but it is important for demonstration purposes. So I'll give you guys a minute to catch up with this. Okay. We can, at the end, we can fix up your stuff if you'd like. Fair enough.
I think I'll go through the video after.
It's streaming right now?
Yeah, I can just make it.
Sounds good. On that note, I don't see any chats. Yeah, I think all is quiet. All right. So, that's all good. Now, So that's cool, but these, we also want, we're actually gonna, I'm gonna change some stuff here. We're gonna actually copy these down to our flow. And because you don't run a task directly, right? You always run a task through a flow. So there's no point in kind of setting these default variables because like no human's going to interact with the task directly because it all happens through the flow. But we can define these at the flow level and then we can just feed them as inputs to our task. Okay? Make sense? Pretty basic. So now let's go ahead and restart our deployment. I know we haven't done all the other stuff yet, but you know, one step at a time. So we've got our deployment up and running. And let's go back to the server here. And let's go back to our deployment. And now this time, I'm actually not 100% sure about this. I think if we do a quick run, oh no, because there's default values. So since there's default values, if we do a quick run, it'll do default values, but we're going to do a custom run. And you can see here that the base URL, the path, we can enter these as strings, and then secure is an optional Boolean, right? What Prefect did was it checked the type hints on our flow's parameters, and then set up corresponding parameters in Prefect server. It is very nice. So in this way, we can say, you know, run with parameters, right? So now we get to see it running with parameters, and we get to see running it with a task as opposed to from the flow directly. Also, another thing worth mentioning, if you want to trigger the run for later, you can do that. If you want to trigger it at a certain time, like maybe it should only run at night. But you don't want to wake up at night and log in the VPN and do all the, like, no, why would you do that? Just schedule it during your working day and then, you know, check it in the morning. Although really you should at least keep an eye on your phone to get any notifications if anything breaks, but you know, anyway. Well, on that note, there are notifications if you want to set up Slack notifications. We're just not covering that today. But, so here I have my run. You know, the defaults are okay. Let's go. And let's go ahead and watch the run. And come on. Now you'll notice here, we got this retrieve from API. That is a task. Okay? So now we're not running stuff from the flow directly. We're running it as a task. It said created a task run, and then it executes the task. You know, it printed our stuff because that's what we told it to do. The task was completed, and then once all the tasks are completed, the flow is completed. Okay? Pretty simple. So far, so good? All right. Let's get more fancy. So, excuse me. So now, at this point, we have our data, but again, we still have 2 more steps remaining. We want to clean it, and we want to insert it. So let's go ahead and do that. Let's define a new task, and let's say clean stats data. Okay, and this will take in the inventory stats. Yes. Yeah. Let's take a short potty break, and I'll actually take a break to just sit a moment because I've been on my feet for a good portion of the day.
I get some water too.
Yeah, go for it. Taking a break. Maybe I should put, in case someone shows up on stream for whatever reason. Oh, hey, look, text. What is a text? BRB bathroom. Totally professional. Short break. Be back in, let's say, 3 minutes. That is just perfect sizing. That is, nothing could possibly, no one could possibly complain about this. Okay. Can I get this like a background? I'm going to try to make this fancy. We're going to make it look nice. I'm totally using my break. Background color, black. Background opacity, yes. Spectacular. I'm going to sit. Oh. should not say be back in 3 because, you know, viewers would not know when that is. Be back. Oh, except they're not going to be able to. Oh, they can see the time on my screen though. So we'll say be back at 1916. I don't know why that's caps. Oh, because I must have hit caps lock. There we go. Oh no. Man, why? Why do you have to be like this? Good enough. What's the one?
My strategy or
You should bring her sometime.
I could do it. Yeah.
We have massage chairs.
Oh.
That's what my girlfriend does sometimes. Sometimes she just goes and chills in the massage chair.
We'd have to bring my daughter.
She can chill in the massage chair too. Or if you bring her out on a Hangouts night, we can like play board games or something. I don't know how old your daughter is though.
She's 7 months. So
Okay, yeah, that doesn't
too
work.
early to do long. But
Yeah.
I mean, if you have nice, colorful things, then she can play with it.
Not so much.
I can see outside you have the target.
Oh, that's just a temporary thing.
Yeah.
Yeah.
That's the so far that would be okay. Although she may.
Yep. Children just try to eat everything.
Yeah, that's where we are. Drop things. Yeah.
Sounds about right. Is my microphone picking up all that background music? Oh man, if it is, that could be a copyright strike on YouTube. Oh no! Oh.
Quiet.
I hope it's so quiet. I haven't tried. I'm going to try to listen real quick. Hold up. Oh no. Oh no. Test? Wait, oh, hi, David. Uh-oh, can you hear me? Oh, no, have we not had audio this whole time? Oh, no, I just have... Wait, is my headset not on? Oh, my headset's not on. Okay. Okay, no, audio's fine. Okay, okay. Can't hear the music. We're good. We're good. Everything is chill. All right. Let's get back to it. Okay. So, we have this task. We are going to add 2 more tasks. We're going to add a task to clean the data, and then we're going to add a task to insert the data. So, let's go ahead and do that. So we only care about the 4 statuses. However, you see this this pet status updated and the string, like these are nonsense, right? So I'm just going to write a tiny little function. And this is probably not the best way to do it, but again, this is just a demo. We're not writing production code here. So we're going to do sold. We're going to do available. Available. We're going to do unavailable. And we're going to do pending. I believe are the 4 statuses that we have. So one thing I noticed earlier, it's not showing up now, but previously there was sold with the lowercase s and sold with a capital S, which that's not great. So what we're going to do is we're going to look at our inventory stats. We're going to get sold like this, and if it doesn't exist, we're going to return 0. We're going to add basically the same thing, but with sold as uppercase. Okay, so that's how I'm going to do it. Again, maybe not the perfect solution, but good enough for now. And then we're just gonna like do one of these numbers, change this to capital, all this super exciting stuff. Let's sit and watch Beege type, boys and girls. I should never be a kid show host. That would be a terrible idea. I curse way too much. All right. So does this all make sense? Any complaints about this? Yeah, this is not rocket science. So that's our cleaning task. And then, for the last one, let's go ahead and do our database insert. So let's say insert to DB. So we want to take in the inventory stats, but we also need like the database connection info. Now, to be perfectly honest, I don't remember how my team does secret info. We do secrets in a sane manner, but I don't remember how off the top of my head, and I did not have enough time to investigate to prepare for this. So we're going to do it in a probably not so secure way. Also, I forgot to do a type hint here. Not that it really matters because we're just saying a dictionary, which is not terribly helpful, but yeah, roll with it. It's fine. So let's do DB host, should be a string. DB user should be a string. DB password should be a string. And DB name should be a string. Okay? Again, not 100% sure this is the best way to do this, but we're just going to roll with it for now. And then we're going to pull in psychopg2. We're going to have to import it. Oh, okay. Import. We'll say connection. And then we'll do db. No. What is it called? Is it just called host? Let me check my notes. Give me a second. Let's see. We'll do user equals db user. And password equals db password, or db pass. DB name, or no, sorry, DB name like this equals DB name, and host equals DB host. Okay, so that's how we establish our connection, except, I apologize guys, I messed up the way I did this. We should say with as connection, so that way it automatically closes. Okay, and then once we have our connection object, we need to get a cursor as well, so we can say with our connection, grabbing a cursor as, let's just call it cursor. Let's go ahead and do our stuff. Okay?
Is that a typo or is that?
That is a typo, thank you. So this is just database connection stuff. You guys have any questions about this? Nah? You good? You guys are familiar with Python context? The with syntax? You all good? Alright, let's move forward then. Man, we're going to finish early. This is going to be great. Alright, so let's real quick, let's take a look at our table here. Okay, so we have the fetch timestamp, sold, pending, available, unavailable. All right, so let's go ahead and set all that up. Let's just do like one of the big things here. And let's say insert into inventory history with the values being, let's not do all that indentation. this is not super pretty. I'm just going to let my linter fix it. I don't really care. Huh?
Is that a PostgreSQL?
Sorry?
What are you writing right now?
This is SQL.
Ah,
Yeah. Sold. Maybe a pending. Available. Oh, typing. Available. And unavailable. Unavailable. Alright. Now granted, I'm not 100% sure these are valid statuses. These are just the statuses I saw when I pulled it while doing testing. It's possible that available and unavailable are... I don't know how they generate the stats for this. I'm just doing something, okay? And then, cool stuff with Postgres. So you have your normal now function, right? Actually, not necessarily Postgres, more like psychopg2. You can do named parameters. So we can say, we're going to have a name parameter called sold. Okay? Let's just do this a couple times. We could do sold, pending, available, unavailable. Okay? Now, these, if I bring this guy over here real quick. Oh, no! That's not what I meant to do. Alright, cool. These map directly to these, right? So the cool part is we can just say inventory stats. Done. GG. Okay? So then psychopg2 will look in this dictionary. If it finds a sold key, it'll use that value. If it finds a pending key, it'll use that value, so on and so forth. Okay? Minimize typing. Questions? I'm expecting at least one, because this bothers me.
Alright, so the width, you said earlier, is everybody familiar with width? I'm not.
Okay.
My question is super basic.
Okay.
But, it seems like, where is it?
So width is...
Doing, but I don't.
Yeah, so width is some special Python syntax. Width is like, man, I keep, like I write a lot of Python, but I swear I'm still a Java developer. It's weird. So width is like, so width is a context. Width is a keyword in Python, where when you run this, when you run whatever this function is, this ideally should be some kind of function, right? And it returns some object, and that object gets stored in this variable name, whatever you want that variable name to be. Now this variable should implement a method called close, okay? Or not implement a method because Python doesn't have interfaces, but just go with it. The object should have a close method, okay? And so when you leave this context, basically when you unindent, it's going to call that close function for you. So basically, and then, yeah. So this connection object gets created from this function call. So it's the output of this function call
And then the same thing's happening
with a cursor. And then we're going to use that cursor object to execute this, to run this execute function. And then when we leave the context, which it's the end of the function, but basically when we unindent, then it automatically calls the close functions on those objects for us. So it'll do cursor.close and it'll do connection.close. It's just syntactic sugar.
So you're using width to make something, but to make something else, but make something else that calls Postgres
And then closes themselves, yeah.
Okay.
So this way I don't have to say like, I don't have to type close.
Yeah.
And I can let the indentation show that, hey, it's also kind of a readability thing, because with the context, the indentation shows that, hey, we're in this kind of state of the code, right? Just like when you do an if or a for or anything, you do indentation, you know, okay, this code belongs to that if. This code belongs to that for, right? It's a block. This is the same, whereas this code is running while the cursor and the connection are open because of the indentation, right? And then we could do something like, we unindent and we say, logger equals get run logger. Oh my god, I cannot type. And then we say logger.info, done, right? but now at this point, the cursor and the connection should be closed. Does that make sense?
So closing connection cursor is implied by the fact that you're using it.
Exactly. Yeah. So so for the benefit of the stream, closing the connection is implied by the closing of the with context by unindenting. Okay. All right. So at this point, we have What's up?
So when you talk about like a single passive transaction, would that be closing the cursor or on the connection?
Single ACID transaction. So do you mean like a single query? Do you mean a single execution, or do you mean like of a transaction?
Like a transaction can have multiple queries, but
Right. So do you mean the individual queries, or do you mean the transaction?
it's a transaction.
Okay. Transactions with PsychoPG2, I'm less sure about. God, I have not done direct database stuff for so long now. Jeez. Transactions are handled at the connection level. And when you do the cursor, when you do the context, I believe it's not only the close method, I believe it also has an auto commit. Yeah. Actually, no, I'm quite confident about that because it behaved like that when I tested it earlier. Yeah. So now,
I'm pretty sure that's like the way it works in MySQL. Just wondering about Postgres.
yeah, they're all very similar. So if it works that way in MySQL, it very likely works similarly in Postgres. And yes, it commits transactions are at the connection level. And closing the context automatically commits the transaction. If you hit an error in the context, it'll automatically roll back the transaction, as I recall reading from the docs. Unless my memory is funky, who knows? People on the internet, test stuff yourself, don't believe me. All right, so back to this. So now we have our 3 tasks. We have one task to retrieve data from the API. We have a second task to clean that data. And then a third task to insert the data to the database. Should we make it go? Pipelines go brrr. I'm too old to be making meme jokes. All right, here we go. Also, I'm not sure that's the proper way to even say that. Whatever. Anyway, so we've redeployed our flow by restarting this agent. And now what the Beege? Get your stuff together. Okay. So now we're going to go back to our deployment here. Oh. We missed something critically important. We didn't actually set the connection variables. Let's do that. So we can do that here. And default value is going to be localhost, because the agent is running directly on my machine. It's not running in the Docker container. Also, this should be a string. The user we set to root. The password we set to root. Even though, just for your general knowledge, root is not the root user in Postgres. The Postgres user is the root user in Postgres. So, Postgres facts. And then the DB name, we called it pet store. All good? All good. Now, before I run this, let's take a look at the database. So server is localhost. System is Postgres. And username is root. Root. Pet store. Go! Bro. Wait, really? Because adminer is running inside Docker land. And so we should use the Docker DNS. It's not doing localhost. So let's try that again. Whee! There we go. Okay. So yeah, it's fine. So we have our inventory history table because that's what we set up as our init. Now select data. There's already data here. This is from my previous testing. Okay, I didn't bother to blow up the database. So there's one record here. This is the current state of the database. Okay, all good? We see one record because we're going to check this to make sure that our flow ran properly. All right. So now we have our database connection info. Oh, but we didn't actually run our tasks. So let's override our inventory stats with the cleaned version of our inventory stats. Okay. And then let's insert the stuff to the DB given the inventory stats and the DB host and the DB user and the DB pass and the DB name. Typing is hard. All good? No surprises here. I'll give you a minute to type. And close this stuff. We don't need this open.
Copy in the README, but all the commands are complaining, so it's
Gross. You're good?
Yeah.
All right. So now let's go ahead and redo our deployment here. Yeah. Okay. All right. And then let's go to our flow. Or let's go to our deployment. Sorry. I don't think we need to refresh. Bro. Man, what is up with... Why do you not like that? Why do you not like us going to it directly? Anyway. Deployments. Pet store. All right, let's do it. So let's do a custom run. Now you see we have all the database parameters here where we could enter stuff we wanted. Again, there is a way to do this nicer where stuff is more secure. I just didn't cover it today. Do not do this in production. This production, bad. Don't do. Nada. Okay? All right, so let's do this as with gusto now. I don't know. We're going to do the thing. All right, here we go. So what we expect is it'll create the flow. It'll do 3 tasks. The first task will pull the data. Second task will clean the data. Third task will insert the data. Let's do it. What is this? All right. And then the logger will print done at the end because we added that to demonstrate the, well, we didn't really demonstrate it with the logger. We should have printed what the cursor's state was, but whatever, it's fine. Oh no! Really? Bro. None type object has no attribute get. I know why. Because. Wait, what? Ha! We never actually returned the stats. I'm a software engineer, guys. Okay. This is why automated tests are important. What you really should do is write tests for each of your tasks. At my company, every task has a test. We do not merge unless you have a corresponding test for every task you write. It's a good policy. Our stuff is quite stable. I recommend it. PyTest. We can do a brief thing, especially because there's a tiny gotcha that you can find out with a quick Google anyway, but we can save you 5 minutes. All right, so let's try this again. I wonder if we just retry, will it just do it without any? Oh, hey, look at that. Yeah, let's do it. Will it? I mean, the old agent is gone, so theoretically it should run the new code. Hey, look at that. Oh no! None type out. Wait, what? Okay, hold on. Where's the retry? Okay, here's the retry. Syntax error. Oh man. Line 14. Wait. Oh. Postgres is giving me that error. Wait, what? Wait, what? Oh. SQL does not like trailing commas. I do that every time because in Python I always add the trailing commas, so I don't have to like worry about missing a comma later. But then SQL doesn't like it, so all my queries get all jacked up. Yeah? Ugh. All right, now let's retry again. Doop doop doop. Doop 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 doop. Doop doop. Doop doop. Doop doop. Doop doop. Oh, hey, look at that. Done. So now, or let's look at the pretty bro. Oh, it's because I'm too. Wait. Bro, where's my cool colored lines. Bruh. Okay, whatever, it's fine. But now, we got data! Yay! Is that time correct? Yeah, that's UTC. Alright, cool. So, we did it. So, just to kind of recap, we have the Prefect server running. Apparently, the Prefect server is having errors, but at least it's got documentation. But anyway, we got the Prefect server running, even if it's having a bit of a conniption. And then, because I'm running it in kind of like local mode and not... So normally with the Prefect server, you set up a dedicated Postgres database and it connects to that and does stuff. But because I'm just running it in kind of like local development mode, it's using SQLite. So another thing to be aware of if you go production with a self-hosted Prefect server. Database is locked. Okay, no idea what that's about. But anyway, we have the Prefect server running. Okay, we configured Prefect to use our local Prefect server because by default it uses Prefect Cloud, which we are not paying for. Although I think you get some number of jobs for free or something. I haven't even looked into it. Because, sorry. One more note regarding Prefect Cloud. I know I'm all over the place here, but just roll with it. If you use Prefect Cloud, none of your data goes to Prefect Cloud. The only stuff that gets stored in Prefect Cloud is the metadata of your tasks. So what tasks ran, when did they run, logs, maybe not even logs. I'm not 100. No, I think logs go up there too. Just that kind of stuff. Your data never goes up there. The flows also never go up there because your flows should be in a separate storage. The flows can either be Docker images or they can just be code files. As long as the agent has a path to those code files, you can even put them in an S3 bucket and it'll grab them from there. So yeah, Prefect Cloud is not all bad. We just don't use it because we already have our own infrastructure and don't want to pay for it, basically. Although maybe their stuff is cheaper than us running it ourselves. We haven't really done the cost analysis. But because we're a health company, like, we can't afford to take risks of whatever data going up there. So we were like, let's not take on any risk, because maybe, like, if the logs go up there and then we print some logs and it has some... Granted, we generally don't store personally identifiable information at all anyway, but if somehow some personally identifiable information gets into our data and somehow it gets logged up to Prefect, we would have a big giant problem. So we just avoid that entirely by using in-house stuff. It might be unnecessarily paranoid, but I'm just describing all this because there's totally nothing wrong with using Prefect Cloud. It saves you all the effort of setting up Prefect server, setting up the Postgres database for it, all that kind of stuff.
Health sector security is no joke.
Sorry?
Health sector security of data is no joke. So I get it.
Yeah.
So like it's specific.
Yeah, exactly. So yeah, if you're doing stuff for the first time, go ahead and use Prefect Cloud. It's nice. If you have like really, really, really hardcore network constraints or whatever, you'll have to do self-hosted. But anyway, we have a Prefect server running. We wrote our flow code. We ran our flow code directly as an agent, which registered with the Prefect server. The flow code consists of one flow that runs 3 tasks. All right. The flow code has these parameters defined. In the Prefect UI, we can look at our flows. We can look at deployments for those flows, and then we can run those flows, and we can set the parameters. We hit submit. That submits to Prefect server. Prefect server talks to our deployment agent. The deployment agent does the work, reports the results back. Everything is cool. And that's pretty much it. Questions before we go on to extracurricular stuff like testing?
When you look at the data,
Sure. So you want to look at the clean data function.
So you said you're using get. I mean, this might. I think this is not understand the concept of cleaning because I thought you're cleaning data when you set it, not get.
So I'm setting it here. So I'm creating a new dictionary with 4 keys. Yeah.
And you're getting it.
From the original thing.
Yeah.
Because the original one has a whole bunch of junk data, which I don't want.
Okay.
So I'm only pulling out the data I want.
Another implied function.
Yeah. So now theoretically, if this were like proper data engineering stuff, I might add some kind of unknown status, and then I might add some kind of info as to like which unknown statuses showed up when and what were their values, because that implies, anytime you have dirty data, you don't just want to throw it away. You want to understand why it's dirty, because you probably still need the data, and then you want to go figure out how to actually clean it properly and then incorporate it into your flow. But in this case, because this is just a simple demonstration, I'm just throwing the data out. Depending on your use case, that may be suitable, that may not be suitable. Your mileage may vary. Does that make sense?
Yeah.
And again, the reason that we're adding 2 retrievals from the dictionary is because I've seen them with lowercase keys and I've seen them with uppercase keys. Maybe there's a way to pull keys that are case insensitive. I don't know of it off the top of my head, and I was in a hurry. So,
It's like a virgin.
Yeah.
That's awesome.
yeah. I don't think dictionaries support regex key search, but I could be wrong. I don't know. Other questions?
Why Postgres? What's good about it?
So the question was why Postgres versus MySQL or whatever, right? To be perfectly honest, in my experience, when I've worked with database people who were really, really, really good, they were using Postgres. When I worked with database people who had no idea what they were using, no idea what they were doing, they were using MySQL. Now, I'm not saying that MySQL or Postgres is better. It's just based on that, if I want to find good database people, I know I'm going to have an easier time finding them using Postgres. At least that's my experience. Maybe that's not the best rationale behind it, but yeah. Postgres does have a couple of interesting things. So, for example, Postgres has their PostGIS, which I think is like Geo Information System or something like that. Basically, you can do like coordinate systems. So like latitude, longitude, this kind of stuff. You can also do shapes as data types in Postgres.
All right. That's very good. That's what MySQL.
Yeah, I think MySQL has something like it, but it's
MySQL.
yeah. So the Postgres one, like we use that. So when we work with medical images, we want to store some of that annotation data, right? But the annotation data is like drawing polygons, right? And we want to do some analysis on those polygons, so we could store them as images, but we'd rather just store them as shapes. So we store them as shapes in a Postgres database. And then for there's also Postgres has a storage engine. It has a time series storage engine, which is actually really nice if you're doing stuff like this. I just didn't configure it. Also, JSON or Postgres has really good support for its JSON data types. Now MySQL does too, but Postgres was a little bit faster about it. And in terms of when I say JSON feels like there is a dedicated JSON data type in both MySQL and Postgres, and they both provide functions where you can extract data or edit data or whatever in those in that JSON data. But to my knowledge, Postgres had it before MySQL. And so, because I remember like seeing it in Postgres and being like, oh, I'll do it in my MySQL database, and being like, wait a second.
Turns out, I just Googled right now the most popular databases in the world.
Yeah.
It's expensive.
Yeah, but like so it's the same reason that like Windows is so popular, right?
Yeah.
Because these companies are like, oh, that company can take the liability, right? So if we just pay a bunch of money for Oracle, they can take the liability. If we have a problem, we can just call them instead of needing to like hire experts, and then we can hire like, yeah.
Yeah, so Oracle, MySQL, Microsoft SQL, plus it is.
Yeah, that sounds right.
I heard like
Now,
about Snowflake. That's new, right? Like,
yeah, but that's not a traditional relational database. That's more data lakey stuff. So in terms of like, so I've never worked with Oracle. I've worked with Microsoft SQL Server. It's not bad. It feels like it's a little heavier than it should be, but it's not bad. And I actually did some crazy stuff with the internals of it, because I was also working with SSIS, which is a really nice ETL system. Yeah, that was actually quite nice. Like Microsoft's developer tools are quite good. I just hate them as a company. Yeah, but like if you're in the Visual Studio ecosystem, you're doing like C# stuff, you're working with .NET, you're working with Microsoft SQL, it's really easy. You just burn through stuff. And in terms of like the people I've encountered, you have all range of knowledge. Like you have people who have no idea what they're doing, but they can still be productive. And you have people who are like, oh no, like it's doing this stuff in memory, all this kind of crazy stuff. I'm like, okay, cool. You know what you're talking about. So yeah, the Microsoft ecosystem is not bad. I just don't like their business practices.
I have issues with Apple.
Yeah, Apple also, I mean, any big company, right? Yeah. Sorry, this is way off topic. Sorry, Internet. Any other questions about the topic today? All right, so let's hop back to the presentation, and then we'll look into testing stuff for a moment. Presentation, okay. So today we covered a brief introduction of what is data engineering and what are data pipelines. We talked about what is Prefect, the tool that we just went over. We talked about the different components of Prefect, flows, tasks, deployments, all these kinds of things. And then we actually went ahead and built a nice little demo of Prefect things. So, we just did question stuff, but one more time, questions? Cool. So additional resources, I just tossed a link to Prefect concepts here. The Prefect docs are not bad. Personally, I think Prefect version 1 docs were better. The version 2 docs seem a little bit less thorough, but they're still quite good. And it is open source, so if you don't understand how something works, you can just go look at how it works. And they are very active. They also have a Slack channel, a Slack server. And we've actually submitted a number of open source contributions to them, and they're very responsive. So, yeah, they're pretty good. I'm a fan. In any case, thank you very much. Let's do that. Okay, there we go. Thank you very much for coming. I hope you guys had a good time. All the typical stuff. We are a registered nonprofit. We should really get on becoming a phase 2 nonprofit so we can do tax deductible donations, but we've been kind of slow. Discord's there if you want to scan it. There's also a text link if you prefer. You can email me. I don't check that email too often. The response time is going to be terrible, but I do check it every once in a while. Discord's your better bet. But yeah, I probably should have waited on this part, but let's take a look at the testing stuff because you're curious about that. We'll come back to this at the end again. So let's say I want to write a test for this, right? Well, first, we should grab PyTest. I'm not going to bother doing a version constraint on here. And let's go ahead and kill this. Let's do pip install. Okay. There we go. And then let's do the thing, guys. Let's do. Oh man, I forget the proper folder structure for this. So I forget if the test folder should be in the source folder or not. It's been a while. I'm not a software engineer anymore. That makes me really sad to say. But let's just make a test folder up here. And then let's make a pipeline module because I am way too... I want things to be matching and pretty. And let's do a... let's just do task.py. So normally, what we actually do at my company is we actually we group our tasks because we have a lot of tasks, and a lot of them are reusable. So we have like inference tasks, we have like data retrieval tasks, we have like data cleaning tasks, and we split them up that way, and then we test per module that way. So just having one giant tasks file is not the way to go, but we're just going to go with it for now. And then we do stuff and things like maybe like this. All right, there we go. So we could do a test of like, let's do the clean stats one because that's going to be easy. Oh no, I don't remember PyTest at all. Let's do def test clean stats data, right? And I don't think we need any dependencies, but they call them something specifically. I just can't remember. Anyway, we can do test output equals some. Actually, can we just go through and get that old bad data? Because that'd be great. Oh my god. There we go. Yeah, here we go. Beautiful, spectacular. So we can just grab this. Just do that over here. Do some like format my stuff, please, or don't. That's cool too. Format. Wait, why doesn't it work? What? No. What are you doing? That's annoying. All right. Anyway. Yeah. Well, it's fine. I'll just be dumb. All right. Cool. That works. And then we can say result output equals clean stats data, right? On test output, or what? There's another name that I usually use for this. What's the proper name? Test input. Come on, Beege. All right, now it's complaining about this because we haven't imported it. Add from pipeline.main import. There we go. Beautiful. And then we can assert result output. We can just do something like this, where sold is 8. Pending is 1. Actually, let's make pending 2, and then let's make pending with a capital as 1. There we go. And then available is 227. And then unavailable as 0. So that tests that we can pull the basic ones. If a field doesn't exist, it'll get set to 0. And we can handle upper and lowercase stuff. Okay? So now we can do, I think it might just be smart enough that if we just do PyTest, it'll just work. Nope. Okay, so if we do PyTest, tests.pipeline, will it find the... Nope. Maybe dot tasks. Oh. Crap. I don't remember how to PyTest. I'm sorry, guys. Give me a second here. I'll just look up a PyTest quick start. Oh. Actually, yeah, what? Oh, maybe. What? I'm bad at this. I am so sorry, guys. What is a -q? PyTest module.
I have a question.
Yeah.
Like when you're implementing one of these tasks, when do you had to just do it in Python versus like making a Docker image for it.
We do everything in Docker.
So every task is a Docker.
Yeah, we do every task as a Docker image. Because we run Prefect on Kubernetes. So yeah, it just makes sense for us. It makes scaling easy. Everything is uniform. We don't have to worry about environment nonsense. I don't know why. Man, I don't remember. I'm sorry, guys. Oh. Okay. What? Oh. Nope. Nope. Fine. We'll just do this. Oh god. New module named pipeline.main. Okay. I am terrible at this. I'm sorry, guys. Because I didn't prepare for this at all. We have to, like... Because what's happening is PyTest doesn't know that it should look like 2 folders up and then into source. So... How about we just...
What's your opinion on PyTest versus
PyTest is better.
That's flat out better?
Yeah, in my opinion. Just because their fixtures stuff is really nice. Yeah. I'm sorry, I'm trying to figure out how to get this to run now. Oh, man, this sucks. Can I specify, like... crap. Oh. Okay. No, I think I know what's up. Crap, man. Maybe I can just move this into here. And then... What? No. Okay, hold up. Sorry, guys. This is a mess. I apologize. Wait, what? Wait, where did I just make the... Okay, there it is. Yeah, that's fine. And then we can just get rid of you. It's fine. Let's try this again. Let's try pipeline.tasks. Will it recognize? Nope. Because why is it trying to do it? I want to do it as... Alright, anyway. What? Source... Oh. You're right, thank you. Okay, right. So, here we go. This is exactly what I wanted to show. And I apologize that we're a little bit over time. But, this is a prefect error. Because this clean stats data, it's a prefect task, not just a normal function. So what happens is, the decorator causes our function to get wrapped in some prefect code. And so prefect's like, okay, I'm ready to run this task. Where's my flow? And then it breaks. So if you want to access the underlying function, and this is what I was planning to do to save you a couple minutes Googling, you just go .fn to call the underlying function. So now we run it. Pass. Just to demonstrate that things are cool, if we set this to 3, cause our test to fail, it says, hey, pending 2 is not equal to pending 3. Okay, so that's how you do tests. But ideally with better code structure. I don't know what's going on here. Why is this still here? I thought it deleted you. What?
So you said you would build all the structure with tests for each module.
Yeah, for each module.
Yeah.
Yeah, you would do tests, usually do tests by module. But you can do it however you want. There's no hard constraints. It just makes more sense because then it's easy like, oh, this module, I want to see what the test for it is. You look at the corresponding test file.
I can see you.
Yeah. Cool. All right, so back to this. Any other questions before we adjourn? Cool. Well, thank you guys. I hope it was helpful. Internets, I hope you're having a good time. And yeah, good luck, have fun.